Okay, this GCSE Chemistry coursework task asks the students to firstly describe the Bohr model of the atom, and then secondly use it to explain the increase in reactivity of the alkali metals as you go down the group. So what I was focusing on is firstly the correct use of scientific terminology, how the students have used to explain these ideas, and secondly whether they've included enough scientific content to clearly explain those two parts of the question. So student 1 clearly sets out her work. Firstly, she uses the first paragraph to explain the Bohr model of the atom very nicely. She makes a nice link to the planetary model of the solar system, comparing the sun as the nucleus and the planets like the electron, which helps the reader understand where she's coming from. And then secondly, she moves on to explain how the reactivity of the alkali metals increases. And she uses lots of very, very advanced technology, like her creating a full octet of 8 electrons in the outer shell to be stable, and valence electron to mean the outer electron. Everything she uses is correct here, except for there's one term which I would like her to improve on, which says the electromagnetic forces causing the attraction between the positive nucleus and the negative electrons, where she actually means electrostatic. It's a very small point, but that tends to make more of an impact, especially if you go on to do further study in chemistry. There's one other thing here, which she has said, everything she said is correct. She says this Bohr model shows that the distance in shells between the valence electrons and the positively charged nucleus gives an idea of the forces between the nucleus and the electrons, but what we're really looking for is to be slightly more explicit, that as the further the electron gets, the distance increases, then the force decreases from the nucleus. So what she almost got it here. She said there was a link, but she just needed to be slightly more explicit in her explanation. So if I move on to student 2, student 2 has got quite a short explanation. What's good is that he manages to describe the Bohr model in one concise sentence. He says it's a positively charged nucleus orbited by negatively charged electrons, which is excellent, so the reader's quite clear. He knows what he's talking about. He also makes lots of other correct statements. Reactivity increases as you go down the group of alkali metals as the electron gets further from the positive nucleus. This is all correct, but what the examiner or what a teacher might be looking for is a slightly more, a deeper explanation of what's going on. So there's a classic example here. The question was, how does the Bohr model explain the reactivity of alkali metals? And he said, the Bohr model explains the reactivity of alkali metals because, and just finished it off with one sentence. That one sentence isn't quite enough. There's quite a few links you need to make there. First of all, the Bohr model includes shells of electrons. The alkali metals have one electron in their outer shell. This electron gets further from the nucleus, so it's more easily lost. And that isn't quite summarized in this one sentence here, even though he does talk about full shells and one electron needing to be lost. There's not that clear linkage, which explains it in the correct and thorough way. So if we move on to student 3, student 3 has done an excellent piece of work. She's structured it very clearly. The first paragraph explains what the Bohr model of the atom is very precisely and gives us a nice diagram showing that the electrons exist in clear shells around a positively charged nucleus. And she uses here the correct terminology. The electrostatic force keeps the positive nucleus and the electrons attracted to one another. And she gives a nice diagram. And then she moves on to explain exactly how this model describes the reactivity of the alkali metals. And unlike the second student, who did explain everything correctly, but perhaps not in enough scientific detail, she does exactly that. She firstly says in group 1, the electron is further from the nucleus as you go down the group. This means there's less electrostatic attraction between the nucleus and the electron. It also means that it's more shielded from the nucleus. All of this meaning that the electron is more easily lost, or she uses a very advanced term here, the ionization energy decreases. That means there's less energy needed to remove that electron. And this, all in total, means that these elements are more reactive as you go down the group. So altogether, she's covered all the bases there, described the Bohr model, and also described the reactivity. So it's a very good piece of work.